This will be a quick video on exploring math. That's the series that I'll call it. So today I actually wanted to talk about the Rubik's Cube. Specifically, we're going to kind of just look at how how the Rubik's Cube changes and how we might be able to map out how it works mathematically. So kind of to start off simple, I wanted to start off with basics. So there won't be any complicated terms. So let's just kind of get started. So with the Rubik's Cube, before we do any sort of like transformations, we can see that there's 6 sides, right? 6 different colors. And so one way we could look at the Rubik's Cube, even before doing any moves, right? Any moves, we can just think of rotating the cube around, right? So if we have the cube facing, for example, the orange side, so this side, if we rotated clockwise, then we get to the white face. If we rotated clockwise again, we get to the red face, clockwise again, the yellow face, and then clockwise. Then we get back to the original orange face. And then, of course, if we do the opposite, we'll just go through it in reverse order, right? So here we see kind of like hints of one way to express just rotations, right? Just how we rotate the Rubik's Cube. And then we could, of course, do that for this way, right? Going up and going down. And of course, in this case, there's also four different rotations that we can do. So we can do it going right, going left, going up, going down. So now we can kind of start formulating like the basics, right? Just the basic rules, right? Without any sort of abstract symbols or notions. Just to get kind of like an idea of how this works. So we can see just by observation that one rotation going to the right, one rotation to the right is equal to 1, 2, 3 rotations to the left. So we can write that one right equals 3 left. And the notation doesn't have to be anything formal, but we could just make up the notation as we go along. So we can just say 1 right equals 3 left. And then we also know that going 2 to the right is equal to going 2 to the left, right? So 2 left equals 2 right. So 2 right equals 2 left. It might be a bit... There we go. I think that's better. And then we can also say 3 right equals 1 left. And then 4 of each is gets you back to the original. Which is actually... So we can actually say that 4 rights is also equal to 0 rights, because we get back to the original. When we do 4 rotations, here, then it's the same as doing 0 rotation. So these are just kind of like a rules that we make up, right? 1 right, 2 right, 3 right, 4 right, and 1, 2, 3, 4. So now we start getting like a picture of how just rotations, right? Rotations of the cube work without any sort of without doing any moves yet, and I'll get into that later. So and we can make the same exact table for up and down as well, right? So with we could just say R equals U for up, and then left equals D for down, right? So it'll be exactly the same. And so now what we can do is, since we can think of doing the right as doing the opposite of going left. So if we go, we can start at, let's see, yeah, the yellow side. So if we go 1, right, if we make one right turn, doing one left turn just inverts it. It just basically undoes the right operation. So we can just make up another term. It doesn't really matter what the symbols are, but we can actually say that now here, right, this is the original. We can just actually say 1 right is equal to, if we translate this, right, 3 left, it's actually 3 right inverse, and I'll just say prime for inverse. And then if we just copy everything else on the table, 2 right equals 2 right inverse, right, which is 2 left. And then 3 right equals 1 right inverse, and then 4 right equals 4 right inverse, and 4 right is also equal to 0 right. Now we start getting like a better understanding of how the rotations of a Rubik's Cube work. So we can basically condense all the rotations we can make, right? Just rotations, no moves. We can condense all these rotations into these groups, right? And since going up is the same, right? Going up is the same as right. We basically capture all the moves we can make just in this one chart, right? We have the right, which is also right inverse, which is also left, which is also up and down, right? So we capture every rotation we can make that has, according to the faces, right? According to each face, right? We capture all the rotations we can make just in this one chart alone. And that's also because we go back to the original, right? Which is 0. So it's like cycling. So it goes 1, 2, 3, 4, and then it cycles back. So we capture all the movements just in this one table. And that's pretty, I'd say that's pretty neat.